Welcome back. Last time we saw how light travels in straight lines and bounces off of things and observed that's how mirrors work. We saw in particular how plane mirrors work. They produce all the same kinds of images. Now you tell me what those images are like. But have you ever seen yourself in a spoon? The front side, the back side? You can see yourself, but they're funny images, right? Have you wondered why it happens? Why you're upside down in the spoon? That is because the spoon is kind of curved. There's special type of mirrors that are properly curved too. We call them spherical mirrors. Spherical mirrors are formed when you cut a part of a hollow glass sphere. Now depending on which side you use as a mirror, like this one or this one, there are two kinds of spherical mirrors. When the surface is used as a mirror and the outside is painted, it's called a concave mirror. And when the inside is painted and the outside is used as a mirror, it is called a convex mirror. So knowing these terms now, can you tell me which surface is convex and which is concave in the spoon? Good, so the front is curved inside, so that forms a concave surface, and the back side that is curved outside is the convex surface. And that, people, makes a lot of difference. You see, because of the geometry and the laws of reflection we discussed, when this light hits a concave surface, the rays are all reflected towards each other. They converge. And when they hit a convex surface, they're reflected away from each other, or they diverge. And it is because of this that spherical mirrors produce all sorts of crazy images. Convex mirrors are just like plane mirrors, except the rays diverge. So to the human eyes, it looks like they're diverging from some point behind the mirror. So the images that we see in that mirror are virtual, erect, smaller, and closer than they actually are. Images in the mirror closer than they actually are. Why is that familiar? Because images in a convex mirror are smaller, they can cover a wider area. That is why they are used as rear view mirrors in vehicles. Coming to the concave mirrors, the rays converge at a point in front of the mirror, like at an actual point that is not just perception. So if you put a screen, like a sheet of paper here, the light actually falls on it and you can get the image on the screen. Isn't that cool? That's how cameras work, but they don't use mirrors, they use lenses that you can learn all about in the next segment. But do you know a cooler thing that uses these kinds of mirrors? Telescopes that look into the far, far universe. This guy Newton, might have heard of him, first got the idea to use mirrors instead of lenses because they were just not working out for bigger telescopes. Because of the way the rays are reflected, the top part going downward and the bottom part going upward, it gives some really interesting images depending on where exactly the object is placed. See here.
Then backing up slowly, approaching the focal point, and my image is enlarging. It's getting bigger. At the focal point, the image gets huge, and then just beyond the focal point, you can see the image is still huge, but it's inverted. And then as I move past the focal point toward the radius of curvature, the image is shrinking in size until at the radius of curvature, the image is now unmagnified. The magnification is 1. Beyond the radius of curvature, the magnification becomes less than 1, and the image is therefore reduced and still inverted.
Cool, right? See, because of the rays on the top going down and the rays on the bottom going up, the image that we see in this mirror is upside down or inverted. This is a property of all real images. They are all inverted. In a concave mirror, you also see that the size of the image varies with the distance. One more thing, if you notice carefully, you could see the image of the man only from certain angle. When the camera was showing him moving backward from a different angle, you couldn't see anything in the mirror. So that's the principles of reflection at work here. Now, if you feel fat or thin when trying out dresses, you can just blame the mirror. It's slightly curved. So, that's it for reflection today, and now we know the secret of those fun house mirrors. I had mentioned that the concept of converging rays are used in cameras to know exactly how. Click on to the next segment. Till then, bye.